So when we calculate the total number of overtime hours, we will divide that by 4 hours per unit to determine the number of units made with overtime. So that's our calculation of the units produced with overtime. This is our calculation of the units produced with regular time, and that will total to our production. Our production has got to be less than or equal to our capacity, and so we transform this to get a 0 on the right-hand side, and we have to move everything to the left-hand side, multiply through by -1 to change the signs, and this will arrive at this equation for our capacity constraint. You know what? I forgot to describe these. So let me go back and describe the workforce size constraint in the model. You can see here, simple calculation, not unlike an inventory calculation. D5 is the workforce minus the D4, which is the workforce in the prior period. We subtract B5, which is the number of hire. We add C5, which is the number laid off. So that is your calculation for that. The Chopra text information I provides complete details for these calculations. Now the production example that I just went through, kind of a long equation here. We take the inputs B23, which is the regular time worker hours per month. We divide by the inputs B21, which is the labor hours required per month. We multiply by D5. D5 is the number of workers. So this is that calculation that we arrived at that gives us the regular time worker hours and units of regular time for each month. Now we add to that the calculation to determine the overtime. Overtime is E5. We divide by that the worker hours per month. That gives us the amount of units produced with overtime per month. And we subtract from that I5. I5 is the production in the period. Okay? So this system will naturally calculate the production in the period given this balance and the required constraint set up in Solver. Okay, so that was capacity. Next we're going to calculate our inventory balance. The inventory balance is for each period is an equality of two parts. It's the inventory balance from the prior period plus production and subcontract units. That's the inventory balance from the prior period plus production in the current period plus the units we purchase on the outside. All of that has to be equal to the demand that is satisfied plus any stock out in the prior period, because we have to supply that stock out in this period, plus the inventory in this period, because that's the balance we have to have at the end of the period, less any stock out for the current period. A pretty long, involved equation. Chopra does a pretty decent job of explaining it. So if you want to look into this balance of inventory for each period, I encourage you to read in detail in the Chopra text that I provided on Blackboard. Now, and of course, in order to have a constraint equation, we need to set this equality equal to a constant right-hand side. So we take everything here on the left-hand side, right-hand side, move it to the left-hand side, set it off against what we had on the left-hand side, and set that equal to 0. This is where our inventory, our beginning inventory, is going to be equal to 1,000. We'll set that up in a constraint. And our ending inventory must be greater than or equal to 500. we'll also set that up in a constraint. Rather than go through all of the details, that is the calculation for inventory. So you can follow through. The actual text from Chopra provides the details of this calculation right down to the cell references. So you'll actually see the cell references in the formula. Next, we have the constraint on overtime. Well, first of all, I want to point out this inventory balance equation is quite involved because it includes the stock out as a part of the equation. So the good thing is the model does consider stock out. It does consider contracting. So it also adds in contracting, subcontracting. So stock out and subcontracting tend to add a level of complexity to this model. Nevertheless, those are natural conditions that all companies face or could face, depending on their aggregate plan. Finally is overtime. The overtime constraint is a policy that's a function of the maximum overtime hours per period per worker multiplied by the number of workers. So overtime hours here must be less than or equal to 10 per worker per month, and that's what this is here. Okay? Transforming that to right-hand side, we have an inequality here. We multiply through by -1. That changes the sign to greater than or equal to 0. And this must be, of course, balanced for each period. Looking at the model, you can see here is the calculation of that. So one thing I want to note there is there's a negative sign, a leading negative sign here in order to get this equation to work correctly. So you're going to see this leading negative sign ahead of E5, which is the overtime hours calculated by the solution, plus the inputs. This here is the calculation of the number of hours multiplied by the hours per unit times the D5, which is the number of workforce, the calculation of your total workforce. So again, all of the details are provided in the outline. So your assignment is to complete the red tomato aggregate planning model in Excel and solve. A template is provided on Blackboard. The optimal solution is 422,275. Extensions for experimentation that are not required for the assignment but are provided in the chapter are to modify the model for higher seasonal demand, modify the model for higher holding cost per unit, and to modify the model with a reduced overtime cost per hour. Those are extensions to that. Just one more thing I want to double check. Did I explain? I didn't walk through the setup for Solver. No, this is important to walk through, so let me do that quickly. First of all, you want to max on the total cost cell, C22. Or excuse me, you want to minimize on the total cost cell, C22. So you want to set it to min. You want to do that by changing the cells, which are the blue cells. So by changing cells are going to be the blue cells up here. This first constraint, B5 to I10, simply assures that all of the values are going to be non-negative. Okay, greater than or equal to 0. The next constraint assures that F10 is this cell right here. Whoops, forgot to shut off my macros. What I'll do is out on Blackboard, I will put the setup for this. Chopra has the same material available, same information available. In his text, he describes step by step all of the setup. But I'll put this out there so that you have that. Also in your options, make sure, okay, I can't do this. I hate it when that happens. Make sure you assume linear. Check the box for assume linear, and check the box for non-negative. Okay, and that concludes that. So I will update Blackboard so you have all of the materials available out there for doing the assignment. I'll have an assignment item out there for everybody to upload their completed solutions. Undergraduates do the dense pack solution. Graduate students do the red tomato. And that concludes this module. Thank you for your time and attention.